Hello, in this video we're going to take a look at a couple more L'Hopital rule examples. So remember, L'Hopital's rule says that the limit as x approaches c of f of x divided by g of x is equal to that same limit as x approaches c of the derivative of the top divided by the derivative of the bottom. So it allows us to take the derivative of each function and give us an easier version of it to take the limit of. It's super useful. However, to use L'Hopital's, when you do that original limit, it has to create the indeterminate form 0 over 0 or infinity divided by infinity. That's the only way you can apply L'Hopital's rule. You can't just apply it to everything. But there are other types of indeterminate forms out there, like infinity over infinity or 0 times infinity. So these are all different ones that if you're doing a limit and when you do direct substitution you get something of this form, you're not sure if it's 0 or infinity or undefined. It's indeterminate. However, they are not of this form right here, which is the only time L'Hopital's rule can be applied. However, with all of these forms, you can manipulate them somehow to get them to be in this form. So that's what we're going to practice with 4 examples in this video, is getting a different indeterminate form into our L'Hopital indeterminate form. So first of all, we have this limit as x approaches infinity of x times sine of 1 over x. And what happens if I do direct substitution? I have infinity times sine of 1 divided by infinity, which 1 divided by infinity is 0. So I have 0 times sine of 0, which is infinity times 0. So that is this indeterminate form. Okay, I don't know if this limit's infinity, because if it reaches infinity first, it's infinite. But if it reaches 0 first, well, 0 times anything is 0. But this limit is not of the L'Hopital indeterminate. So what can I do? It's actually pretty easy. You take one of the functions and you take its reciprocal so that it comes on the bottom. And typically, if you have an x, you're going to reciprocate that one. So notice how I wrote this. This is the same as the original function, because if I multiply both by x, this becomes 1, so nothing down there, and I have my original. So I take that x and I divide by its reciprocal. Okay, that's essentially what you do. To take a product indeterminate, you take one of the functions and divide by the reciprocal. I can now apply L'Hopital's rule. So this equals the limit as x approaches infinity of derivative of sine 1x, that's a chain rule. So derivative of the outside function is cosine, evaluated at the inner, and then times the derivative of 1 over x is negative 1x squared. That's a little power rule. And again, the bottom derivative of 1 over x is negative 1x squared. Okay, can I do this one? Well, let's do a little algebraic simplification first. We can multiply by negative x squared. So basically multiplying by the denominator. And if I do that, I have some nice cancellation here, leaving me just the limit as x goes to infinity of cosine 1 over x. Now if I do direct substitution, does it work? Well, you can think of it as giving cosine of 1 over infinity, which that would give 0 again, and cosine of 0 is 1. And so that's the limit. Okay, so to take a product indeterminate, you take one of the functions and divide by the reciprocal, which is what we did to get this. And do notice that what I have there is the indeterminate, because if I plug in infinity to the top, I get 0, and plug in infinity to the bottom, I also get 0, because 1 divided by infinity is 0. Okay, let's try our second example over here. This time, I have sine of x to the x, and what happens if I plug in 0? So it's 0 from the right, but we can still do direct substitution even though it's a one-sided limit. Well, this is giving me sine of 0 to the 0th power, which is 0 to the 0, which is indeterminate. Indeterminate because if I reach this 0 first, 0 to any power is still 0. But if I reach this 0 first, anything to the 0th power is 1. So is this limit 0 or 1? Not sure. Okay, But I can't do L'Hopital, so what do we do? This one is actually sort of involved. We're going to do a little logarithmic work with it. So we're going to say y is equal to the limit of sine of x to the x. So I give an equation here so that I can take the logarithm of both sides, and it gives me ln of y equals the limit of x approaching 0 of natural log. So just there we use the property that you can bring a natural log inside a limit. And then because of logarithms, I can use the power property and bring down that x. So I have x times natural log sine of x. Now what do I have? A product indeterminate form. So then I take the x and I divide by its reciprocal, give me ln sine x is equal to 1 over x. And this gives us an indeterminate form of infinity over infinity. But this is where it's important mathematically why it approaches from the right. Because if I think of ln of 0, which is what we get because sine of 0 is 0, e to what power is 0? Well, you can't do that. But if you approach from just one side, there is the one-sided limit, and in fact is negative infinity. So you're given negative infinity divided by 1 divided by 0 is infinity. So 1 divided by something really, really small is infinity. Okay, so negative infinity over infinity, that classifies as an indeterminate form we can do. So we are going to apply L'Hopital's rule, and we will take the derivative. So I have a chain rule with the ln sign. So its derivative of the outside is 1 over x, but evaluate at the inner, times derivative of the inside function over the derivative of the bottom, which is this. This is going to give us the limit as x approaches 0 from the right of cotangent x over negative 1x squared. Okay, cotangent, because that's cosine over sine. Oh, and I'm sorry, we did not do L'Hopital's, so I just need to put equals. Now this equals, let's see if you can stick with this, negative x squared times tangent x. So basically I took the reciprocal of each, but that caused me to flip the fraction then. Now if I do this direct substitution, what happens? I get 0 over 0 because tangent of 0 is 0. So I'm still indeterminate. So guess what? We will apply L'Hopital's rule again. And this gives me the limit as x approaches 0 on the right of negative 2x over secant squared x. Okay, so now can we do direct substitution? Well, this is then going to equal 0 divided by, what is secant of 0? Well, secant squared x is equal to 1 over cosine squared x. So this is 1 over cosine squared of 0, which is equal to 1 over 1. So we get 1. And 0 divided by 1 is 0. So is our limit 0? Hold on one second. What do we have up there? The answer, y does not equal 0, but ln y equals 0. So our last step is to exponentiate both sides, because then those cancel and we get y is equal to 1 because e to the 0th is 1. Wow, that's involved, but there we go. That is the answer to that limit. All right, let's try two more. Okay, let's try these two now. So I have the limit as x approaches 2 from the right. If I try direct substitution, I get 8 over 0 minus 2 over 0. And that would give me infinity minus infinity. That's indeterminate, because if I reach this infinity first, infinity minus anything is infinite. But if I reach this infinity first, I would have anything minus infinity giving me negative infinity. So is it positive or negative infinity? Well, let's see. So it's an indeterminate form, but it's not of the correct L'Hopital form. So when we have a difference indeterminate, so infinity minus infinity, what we do is we just add the fractions together. Easy as that. So what do I need to do? I need to multiply this by x plus 2 over x plus 2 to get the denominators the same, because you should recognize that this factors as a difference of squares. So this gives me the limit as x approaches 2 from the right of 8, nothing changing there, minus x squared plus 2x over the same denominator. Okay, now we can combine our fractions. We get negative x squared minus 2x plus 8, if I put it in standard form like that, over x squared minus 4. So what if I try direct substitution now? I get negative 4 minus 4 plus 8, which is 0, over 4 minus 4, which is 0. So our indeterminate form. We can apply L'Hopital's rule then. Alright, so we're going to do L'Hopital, limit as x approaches 2 from the right of negative 2x minus 2 over 2x. Alright, now if I do direct substitution, and I always love doing L'Hopital's rule on polynomials, it makes it really easy. Okay, now we do direct substitution. If I plug in 2, I get negative 4 minus 2 over 2 times 2, which is giving me negative 6 over 4, which negative 3 halves turns out to be the result here. Okay, and let's try one more example then. This time if I plug in infinity, I get 1 plus 0 divided by infinity, which is going to equal 1 to the infinite power, another indeterminate. Here, if I reach 1 first, 1 to any power is just 1. But if I reach infinity first, well, anything to the infinite power is going to be infinity. So, which is it? Okay, we got indeterminate, but we get to get this into L'Hopital form. So we will apply that same idea of taking the natural log of both sides. So I'm going to set my function equal to y, and then we'll take the natural log of both sides, giving me natural log y equals the limit as x approaches infinity of the natural log of that function. And we do that again because we want to be able to use the power property and bring down that x. So now I have natural log of this. And now because I have a product, I'm going to apply once again that technique of dividing by the reciprocal of one of the functions. And again, we will apply that to the x. So I have 1 over x. Here I have the indeterminate form of 0 divided by 0. Okay, because if I plug infinity in, I would get natural log of 1, which is 0, divided by 1 divided by infinity, which is 0. So we can apply L'Hopital's rule. So it equals the limit, and let me apply L'Hopital's, as x approaches infinity. Derivative of the top is 1 over the inside function times derivative of the inside function. So derivative of 1 plus 1 over x is this, and divided by derivative of that bottom, which is again negative 1 over x squared. Which this works out nice because now in my next step of simplifying, I'm going to multiply by the reciprocal of the denominator, and these cancel out, cancel out, cancel out. Beautiful. So this is giving me the limit as x approaches infinity of 1 over 1 plus x. And now here, if I do direct substitution, I have 1 over 1 plus 1 over infinity, which is 1 over 1 plus 0, which is 1 over 1, which is 1, as you may have seen. But remember, that's not the final answer. This is all equal to natural log y. So I have given myself the equation natural log y equals 1. So if I exponentiate both sides, y is actually equal to e. So our answer is e. Alright, so there's 4 examples of 4 different versions of indeterminate forms that we can then force into the L'Hopital version, 0 divided by 0 or infinity divided by infinity. So I hope those techniques are useful for you.